What does a group of community college students, a $500 budget, and a lizard all have in common? They're all part of a robotics challenge run by the Colorado Space Grant Consortium. The goal is to build a fully autonomous rover capable of navigating Mars-like terrain with strict limits on weight, cost, and time. We are a high school team from Pueblo Community College. Now let's introduce you to our crazy team members.
I'm Micah.
I'm Liam.
Oh, hi there. I didn't see you there. I'm Ben.
And I'm Daniel, your narrator, and also the only sane team member here. We also have another team member, whose name is Roberto, who is lame and decided not to be in this video. Now, I will explain our brainstorming process and how we came up with the idea that we ended up utilizing in the end. We started with group brainstorming sessions, where we all worked together to jot down a numerous amount of ideas. After that, we worked together to prototype the different ideas using Legos and simple 3D printing. After that, we revised some of our original ideas, created some new ones, did some last-minute prototyping, and then we were finally able to come up with our final design. Our brainstorming process also sometimes involved swords, because swords are awesome. Now here's some more information on the final design that we came up with. We decided early on that our main goal with the rover would be to test the use of rotating articulation. To this goal, we decided to create a robot with 3 different segments. We also decided to use a special monocular slam system for advanced autonomy. Now, Ben is going to talk about how he created our custom articulation and body.
Let me show you what I've been working on. I mostly worked on the body pieces and the articulation for our rover. Our articulation was based off of reptile vertebrae. We wanted to have flexibility in all directions, so we designed this. Ooh.
Now, Liam will present how he created our custom wheel design.
Behold, the wheel. It would seem that I forgot something. There are many wheels. This wheel, I made it. 3D printed it myself, custom design, PLA. You see, this wasn't good enough, though it was good. This one was good.
Now Micah will discuss the electronics.
These are the electronics of the rover. Raspberry Pi in here. We got it all wired up. Got some ultrasonic sensors. We open this compartment, buck converter. Got a motor controller. Take a second here. We got some motors right there.
Now, I will do a quick overview of how our custom SLAM system works. For those of you who are unfamiliar, SLAM stands for Simultaneous Localization and Mapping. Our rover uses this system via a monocular slam, which means we're using a single RGB camera. We're currently running ROS2 Jazzy with Ubuntu 24 on our Raspberry Pi 5. The system leverages OrbSlam 3 to perform real-time visual feature extraction, localization, and map generation at roughly 30 frames a second. When the SLAM is running, it generates a point cloud and a localization coordinate. The generated point cloud is converted into a 2D laser scan for efficient navigation, enabling obstacle detection and path planning through custom control nodes. If visual tracking degrades or the camera becomes blocked or loses track of the SLAM points, ultrasonic sensors will then provide fallback distance data, ensuring continued operation of the rover. Now, the part you've all been waiting for. How did our rover perform at the Robotics Challenge? The Robotics Challenge was held in Alamosa, Colorado. The day before the Robotics Challenge, my team and I all drove up there. That evening, there was a large group workshop where we were able to put the finishing touches on our rover. Later that evening, we stayed up late, making sure that everything would work the way we wanted it to. Then, the day of the challenge arrived. Everyone met at the Great Sand Dunes National Park. Our rover was good to go and we were ready to test it. And the question was, did the rover perform to expectations? And the answer?
It really didn't make it through any courses at all. Pretty bad.
Yeah, it kinda broke. So essentially what happened was all of the individual components worked very well, but due to our lack of testing, there were some unforeseen issues. Mainly the fact that the robot just kind of went in circles because it didn't know how to correct itself to drive forward. Now we'll hear from some of our team members and from some spectators about what they thought about the performance of our rover. Alright Ben, what did you think about the challenge?
Well, I thought it was a lot of fun. All of our systems worked great. They did not work very great together though. It's fine. It doesn't matter.
Welcome back to... It was good. Got it running, which was the hard part. I think that it really didn't make it through any courses at all because we had to help it.
We didn't really get through any of the courses. We had the slam working. The articulation worked pretty well.
So, in our challenge, we really did quite tremendous. We did it, Mr. President!
Oh, don't put me on this video. I think the Clanker Collective did an amazing job. However, the lack of consistent input from all parties caused some issues.
In summary, the main aspects of the rover worked very well. Our rotational articulation worked perfectly, showing that this technology can definitely be used for improvements in the field of rough terrain robotics. Our SLAM system also performed very well, showing that a monocular SLAM can easily be used in outdoor environments for advanced navigation. However, our prototype did not blend these two aspects together very well and was lacking testing. So yeah, that's pretty much it. Thank you for watching our video.